What is network address translation? Before we get into the concepts, let us go through a small backstory on the evolution of Internet and the IP addresses. Computers need IP address to communicate with one another. Computers send data in the form of packets. So when we send data over Internet, we need to include the sender's IP address as well as the receiver's IP address within the packet so that the packet can travel over the Internet and reach the recipient. Back in 1970s, when they were designing the IP address, they had two thoughts. If we have a smaller IP address, it will result in a smaller packet size, which will travel faster over the Internet. If we have a bigger IP address, it will increase the size of the data packet and it will result in the network congestion. On the other side of coin, having a smaller IP address means very less number of public IP addresses. And having a bigger IP address means it will support huge number of IP addresses. After facing this struggle, scientists decided that they will go with 32-bit IP address, which translates into 4.2 billion public IP addresses, which is good in 1970s. But now we have 7.5 billion people all over the world. And to add fuel to the fire, everyone has multiple devices nowadays, and they want all the devices to connect to the Internet. So clearly, we have a problem. Having only 4.2 billion devices connect to the Internet is not an option. We need to figure out a solution. The fix is network address translation. With network address translation, you get one public IP address per home, and within your home and within your local area network, you can have many private IP addresses. With network address translation, we can overcome the limitations of IP version 4 as well as have all our devices connect to the Internet. Here's a typical home network. We have John's laptop, we have Jane's laptop, and we have Jane's iPhone. All these three devices are connected to our home router. Our home router, in turn, assigns a private unique IP address to each of these devices. If we notice here, the 192.168.1.2 is a private IP address. The IP address is local to our network. This is also called as local IP, and it is not visible outside our home network. The router, in turn, connects to the Internet. When the router connects to the Internet, it gets a unique public IP address. This is what is visible to the outside network. The ones on our left is the local area network, and the ones on our right is the wide area network. In case if you notice these IP addresses are familiar to you, it is because this 192.168 IP range and 172.16 IP range and 10.0.0.0 IP range are all reserved for private IP addresses. Based on your home router, you should have one of these private IP addresses assigned to your laptop or mobile device in your home. Consider an example. Jane wants to check the weather in Dallas, Texas. Jane uses her iPhone to check the weather. Currently, her iPhone has the IP address of 192.168.1.4. When Jane uses her iPhone creates a data packet. The data packet contains the source IP address, which is 192.168.1.4, and the destination IP address, which is the AccuWeather server's IP address, which is 2.3.4.5. She sends the data package over the Internet to the AccuWeather server. The AccuWeather server processes the information that Jane needs, and then it tries to send the information back to Jane. Now it couldn't find the IP address because the IP address that Jane used was a local IP address. It is a private address and it's not visible outside the home network. So now the AccuWeather server cannot send the information back to Jane's iPhone. It is a problem. This is where we need network address translation. This is where the router comes into picture. Let us rewind it a little bit and then say the iPhone generates the data package which contains the source IP address as well as the target's IP address. Instead of sending it directly to the AccuWeather server, Jane sends that data packet to the router. Our home router then uses a network address translation table. This is the intelligent translation that the home router does. It uses the private IP address and then it translates that private IP address into an equivalent public IP address. And then it modifies the data package. It spoofs that private side of the IP address and it replaces with the public IP address, which in our case is 12, 13, 14, 15. And it sends that package to our AccuWeather server. Now our AccuWeather server processes the information and it creates a package and it sends that data packet to our home router. Since our home router has the public IP address, now our home router again uses the network address translation table. It finds out the correct recipient for that particular data packet and then it forwards that package to Jane's iPhone. This is how network address translation happens on your router. Network address translation is simple, it's transparent, and it's automatic. Jane doesn't have to worry about all the private and public IP address stuff. The router uses this network address translation table and it takes care of everything on its own.